Hello everyone. In this video we are going to talk about a few past paper questions about differentiation in paper 3. This is the list of MF19 formulas. First example, the diagram shows the graph of y equals e to the power of cos x times sine to the power of 3x, x between 0 and pi. We have maximum point. We need to find the x coordinate of M. So first of all, we have this formula. If y equals cos, y prime is minus sine. So cos becomes minus sine becomes cos. And if we have e to the power of something, the derivative is exactly the same times the derivative of the power. So for this example, if y equals e to the power of cos x, the y prime is exactly the same times the derivative of cos x, which is minus sine x. And if we have some function to the power of n, derivative is n times the same function but the power is n minus 1 times the derivative of that function. So for example, sine x all cubed, bring the power down 3 times sine x, the power now is 2 times the derivative of sine is cos. So if we find if we have y equals e to the power of cos x times sine cubed x, we identify the u and the v first, and then we find the u prime. The u prime is the derivative of e to the power of cos x, which is from here we get minus sine x times e to the power of cos x. This is the u prime from here. The v is just this thing here, exactly the same. The v prime is the derivative of sine cubed x. Here the derivative of sine cubed x is 3 sine squared x cos x. So this is for the v prime from here. The u is just e to the power of cos x. And now let's simplify. Sine x times sine to the power of 3x becomes sine to the power of 4x. And if we factor out e to the power of cos x sine squared x, you can factor out this. We get minus sine squared x plus 3 cos x. And notice that when you expand this times this, you get minus sine to the power of 4x times e to the power of cos x. And here if you expand, you'll get this again. So we have the y prime. Now stationary point means the y prime equals 0. So this y prime is equal to 0. And that means this whole thing can be 0. But of course e to the power of cos x can never be 0. So that means the sine squared x must be the 0. And therefore sine x equals 0, the x can be 0 or pi. So we use inverse sine 0, we get 0. And this is from 0 to pi. Now the second possibility, from minus sine squared x plus cos x, this is equal to 0. So we can use the Pythagorean. Sine squared becomes 1 minus cos squared. And let's simplify this quadratic in cos x. We get these results. Remember the a is cos x, so the x is inverse cos this value here. And for this guy here, if you try using inverse cos this fraction, you will get a math error because this is smaller than minus 1. So in conclusion, in 2 decimal places, we get this. Alright. Yeah, this is the same. Let's just do this one. Find the exact coordinates of the point on the curve at which the gradient of the tangent is 1/4. Ln becomes 1 over, and this is the quotient rule. So if y equals x over 1 plus ln x, we have the u and the v. Find the u prime and the v prime divided by v squared, and then we get, oh, this is just 1, so ignore it. It's just 1 plus x. 1 over x times x is 1, so minus 1 divided by, and 1 minus 1 is 0, so we have ln x over 1 plus ln x all squared. And now to find the tangent gradient, the tangent gradient is 1/4, so this is 1/4 tangent gradient. The f prime is from the previous solution here. Now we can cross multiply. This is what we get, and you can expand the quadratics. This is what you get, and you can move 4 ln x to the left, so you have minus 2 ln x, and we get the a. So we have only one single solution for the quadratic here, a equals 1. So now ln x equals 1, the x must be e then. For the y, you can just replace the x in the original question here. So this is this is the function y here. You replace the x with e, we get e over 1 plus ln e. So ln e is 1, so e over 2. And therefore the coordinates of the stationary point M is e 1/2 e. Alright, okay, this one, by differentiating cos over sine, we can, cos over sine is cotangent actually, and the derivative is, this is from u prime v minus v prime u. Alright, we have also parametric examples in implicit examples and inverse tangent. Yes, you can just read the rest on a Google site. Right, I'll see you again next time.